have to play a complete book, but I do not like this chapter again. Yeah, but I would be exporting it so that we get it in one of a kind of a place. That is Flexit. That's my favorite app, by the way. Oh, I already did it. So maybe this is going in the bin. Okay, this one. This one it is. We'll study about acid, bases, ionic products, pH scale, pH calculation, salt hydrolysis, buffer solution, and solubility. Electrolytes, and if we say 19 pages are there, which means 18 pages, but we are at page number 3, which conduct electricity in the aqueous or in molten state are called electrolytes. In aqueous or in molten state is important, others do not, and others referred as non-electrolytes. Substances can be electrolytes, sugar, urea, etc. can be strong or they can also be weak. Strong is strong acid, strong base, and salts. Weak are weak acids, weak base, and sparingly soluble salts. These were the categories. Next is the acid-base concept. There are 3 types of concepts here. First is the Arrhenius concept, where the acid is like gives H plus and base gives OH minus in aqueous solution. H plus plus H2 is equals to H3O minus hydronium ion. Bronsted-Lowry base, the acid is an H plus donor while base is an H plus acceptor. Strong acid, weak conjugate base, weak acid, strong conjugate base, weak base, strong conjugate acid, strong conjugate base. Acid minus H plus is equals to conjugate base plus H plus is equals to acid. Lewis concept, electronic concept, acid electron pair acceptor, base is an electron pair donor, by the way. Next is ionic product. What is an ionic product? H2O, this is called the ionic product, that is the hydronium ion plus OH minus. So H2O is equals to plus OH minus. Ionic product at 25 degree it's 10 to the power minus 14. At 90 degree 10 to the power minus 12. Temperature increases, the Kw, the ionic product, increases. Pure water has same number of H plus and OH minus ions, which is this. Acid has number of H plus ions more than OH minus, and the base has OH minus more than H plus. The molarity of the water is 55.5. What is the pH scale now? pH scale is calculated as minus of log of H plus POH is equals to 10 log OH minus KW যাই হবে just সেটাকে minus of log of সেটা করে দিতে হবে। H plus যদি আমাদের বলে x 10 to the power minus y, তো pH কি হবে? pH হবে is minus log of x into 10 to the power minus y. Then what we will do is it gets differentiated as minus of log x plus log 10 की power minus y, which is minus y, this is minus, then it's plus minus y minus 10 तो x, this gets broken up like this. So Kw is equals to तो pKw is 14 at 25. pKw is equals to pH plus POH as this, and pH 14 because the value of pKw is 14 at room temperature. If we go more than 7, it's basic. If it's going less than 7, then it's acidic. At 90, the pH plus POH is equals to pKw, that is equals to 12. We have done this already. Weak acids such as acetic acid, if we go, in this case what happens, we have to find an ionization constant. How is it find? The concentration is that, this is the dissociation constant, the CHO, and this ionization constant. Ionization constant pK is equals to minus log of K, which is the similar. Now the ionization constant happens to be C alpha square minus 1 by alpha. If alpha is very less than 1, or 1 minus alpha is approximately equal to, then 1 minus alpha is approximately equal to 1, and Ka is equals to C alpha square. And in this case, alpha can be equals to root over Ka by C. So this, I've just broken down, let me show. If this is C, then C minus C alpha, this would be C alpha, this would be C alpha. This is C square, alpha square, and C minus 1 minus alpha, this gets, then C alpha square is equals to 1 minus alpha. How is this takes place? So you can just substitute the things. The pH, what is the pH here? The pH would be here half of pKa minus log of C. This is for weak acids. For weak bases, the process is same, but it's half minus pKp, association constant, the dissociation constant, minus log of C. The pH calculation of strong acids and strong bases. Case 1, when the concentration is more than, these have the same like done pH calculation of strong acids and bases. Normally the acids are base with the concentration H plus 2 molar of H2SO4. This acid plus acid. In case of dilution, use the formula of N1V1 is equals to N2V2. Acid plus acid or base plus base, use N1V1 is equals to N2V2. Acid base N1V1 minus N2V2 is equals to N3V3. Now, this is in the case when the concentration is more than 10 की power minus 6. If it is lesser, ठीक है, it is lesser. See if H3O plus is equals to 10 की power minus 7, 10 की power minus 4, 10 की power minus 9, then it is definitely equal to 6.7. And if it is, in case of this is 7.1, just add or subtract a 0.1. Calculation of mixture of two weak acids or two weak bases. If we are talking about two weak acids or two weak bases, the H plus is equals to C1 alpha 1 plus C2 alpha 2. pH log is the log of this. You get it what we are talking about. Similarly, in this case, number 10, dipolybasic dipolyacidic bases. H3PO4, 3H plus plus PO4, 3 minus. That is stepwise ionization constants. Wow, this is pretty though. Now we go hydrolysis. Strong salt, acid and weak base. Acids forms a weak base in the chemical reaction. Then it is hydrolysis. This is a cationic hydrolysis. The pH is less than 7. Salt of weak acid and strong base. Then it's an anionic hydrolysis. Salt of strong acid and weak base. Salts of weak acid and a strong base. Constant degree of hydrolysis, just the same of degree of dissociation, only is number of moles. The pH calculation, strong acid plus weak base. 7 strong acid plus weak base. pH of pK, half pKa minus half of log C. Weak acids plus strong base. Salt of weak acid plus weak base.